Hey guys, it is our first video in a little while. We've had a couple days off. Found a bonus day yesterday. Today's notes were pretty quick and easy, so there's no video for those. However, if anybody decides that they really need a refresher on that, I will be happy to put something up on the website for you. Um, I do have a full belly now, so maybe I can get through this. I don't know what compelled me to only eat a bowl of Cheerios today and nothing else, but I'm feeling better. Um, we're going to talk about organizing qualitative data with this set of notes, and we discussed kind of the differences between qualitative and quantitative today. Um, Remember, we also talked about quantitative data. You can have discrete and continuous. Qualitative data is a non-numerically based data set. So we talked about gender being male or female. That would be a data set, and it has a non-numeric value. A lot of times in statistics, there's a lot of terms that come up, and they are pretty straightforward in their definition. Um, you just have to get used to the terminology. So you can see right here, the first thing we're going to talk about are frequency distributions. Frequency distribution, it's really simple. It just simply means counting what you're looking at. Um, There in the green box, you can see that a frequency distribution of qualitative data is a listing of the distinct values and their frequencies. So to construct a frequency distribution of qualitative data, it probably would just help to go on and jump into an example and see how that works. So we're given that a statistics class was polled, and they were asked what their um, political party affiliation might be. The choices were Democratic, Republican, or other. So we want to come up with a frequency distribution of this set of data, and all we got to do is go through and count. So I'm going to use blue for the Democratic students. So we have, and that is yellow. Let's try this again. Blue, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So Democratic, we have 13. Republican will be pink, so 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. And other we will do in green. 1, 2, 3, 4, 5, 6, 9, and that looks to be 9. So let's just add these up to make sure, because it does say that we had 40 students. We want to make sure that we didn't miss one of our data points. So 13 plus 18 plus 9, 31 plus 9 is 40. So it does check out. So we have come up with all of the frequency values for this particular set of data. We have 13 Democratic students, 18 Republican students, and 9 who claim to be of another party affiliation. So that's pretty straightforward. That's a frequency distribution. The next thing we're going to talk about is what's called a relative frequency, and a lot of times you can simply think of that as a percentage. So we're going to refer back to our previous example. The majority of the time in statistics, you can see right here, I'm going to highlight it in the middle of the screen, the relative frequency of Democrats. It's the frequency of Democrats, so that's how many we counted, divided by the total number of observations, which was 40. And when we simplify that, we get 0.325. So that gives us the relative frequency distribution for students who claim to be Democrats. And we could just simply multiply that by 100 and convert it to a percentage. Now, just like with percentages, everything should add up to 100. So with relative frequency, if we are just simply using the decimal values, we add all the decimal values up and it should add up to 1. So relative frequency would total somewhere between 0 and 1. And if we did it as percentages, it would be 0 to 100. So we're going to obtain a relative frequency distribution of the political party affiliations from example 1. And if I recall, we had Democrats was 13, Republicans were 18, other was 9. So when we compute the relative frequency for Democrats, it's 13 over 40. That one was already done for us. It was 0.325. With Republicans, it's 19 out of 40. And I'm going to type that in real quick. Bear with me. We get 0.475. And then our last set is the students who identified as other, and that would be 9 out of 40. And when we type that in, we get 0.225. If I add all these together, 0.325 plus 0.475 plus 0.225, I do get 1.025. So that is slightly greater than 1, and the reason that is probably greater than 1, if you look at our values, 13, 19, and 9, 13 and 19 are prime numbers. We're dividing it by 40, and these, every single one of our values, we've rounded to 3 decimal places. So this could be due to a rounding error, but rest assured that it all does add up to 1 if we had used all the decimal places. So chances are some of these are non-repeating, non-terminating decimals, and that's why we have this rounding error. But you can see, though, that it is pretty close to 1, and you're going to encounter that from time to time. There's a lot of graphical ways to represent qualitative data, and these are all going to be things you have seen before. So it's really, this is still kind of like what we did today was just an introduction to some terminology today. This set of notes right here is going to be a lot of just refreshing you on things that you've probably already seen in the past. So a pie chart is one way to represent qualitative data. It's really kind of straightforward. If we take the values that we came up with, for example, to 0.325, and we convert that to a percentage, it's 32.5. And then we have 47.5%. And then we have 22.5%. So we can take those 3 percentage values and we can put them into a pie chart. And you can see right here, it's really just as simple as, if you're constructing a pie chart by hand, it's 360 degrees in a circle. 45% of 360 degrees would give you this angle within the circle. 22.5 degrees of 360, or 22.5% rather, of 360 would give you this angle in light blue. And then 32.5% of 360 would give you that other angle. And you could draw it by hand. What I'm going to encourage you guys to do is to acclimate yourself to the different graphical representations that you can utilize in Microsoft Excel. I'm pretty sure Google Sheets has the same capabilities. I've not really used Google Sheets a lot in this capacity, but I have used Microsoft Excel a lot, and we will go over some of these things together in class. I don't want to do it on a video because I'd like for us to get together with the Chromebooks out, and I'm going to explore the capabilities of Google Sheets a lot more so that we can all be on the same page and work on this together. But you can use a lot of technology to do these pie charts. I'm not going to say you have to do them by hand. However, if you choose to do them by hand, I would strongly encourage you to use a compass and a protractor. Make sure you get your angles as accurate as possible when you do these, so that the visual representation is really close to representing the actual data that you have. Another graphical representation are bar charts. Again, this is something you've probably seen before. With a bar chart, it's going to be a situation where you have the relative frequency or the frequency, whatever the case might be. So you can use the count or you can use the relative frequency on your vertical y-axis. And then across the bottom on the x-axis, you're going to have your variable. And in the case of, we're going to continue with the same example. So in this case, we have students who identified as Democrats, students identified as Republicans, and then students who identified as other. And we're using the relative frequency in this particular graph. If I'd changed it and done the frequency of students, the graph actually would look identical to what we see right here, but it would just have different values on the vertical x-axis, and it would have different values above each bar, indicating the exact values that are represented by those particular bars. Apologize for that. I was interrupted by the people who live here with me in this house. Misty, no cats. There's no cats in this house, so that's one thing I've got going for me right now. Jaron, I apologize to your cat. I'm sure that your cat is an angel. So we're talking about bar charts. Again, this is very simple to do. One of the key things about a bar chart is you do not want the bars of the graph to be touching one another. That's an entirely different visual representation called a histogram. We're going to talk about those later. But with a bar chart, you do want space between the bars that represent the data that you want to visually demonstrate to your audience. And that's it. This is a quick video. Look, less than 12 minutes. I'm going to talk for another 25 seconds. Maybe we'll make it 12 minutes. But this really should be pretty straightforward, and I'm happy to answer any questions you guys have. One thing I do want to mention too real quick, I don't know if I have anything in this set of homework, but a lot of times when I reference a particular study or an article that has been published, I'm going to put a new tab in our website. I do encourage you guys, I know that you guys have better things to do than read some statistical analysis and read some of these papers that are written, but I do encourage you maybe from time to time to take a moment and maybe read one or two of them. Here's an example right here, number 7 on the homework, using Adlerian theory to shed light on drug dealer motivations. That article is published, it's going to be on the website. So you can actually look at some of the data. You can look at how these particular statisticians evaluate and analyze the data. And it might give you guys some insight into how you may want to conduct your own statistical study. You know, I mentioned today that we're probably going to replace one of our tests with a project. And that project is going to be developed and built up over the course of several weeks. It's not going to be something I'm going to say, okay, you got a week to do this, now do it. You'll have time to think about it and plan for it. But that's it for this video. This is section 1.5, organizing qualitative data. The next video is going to reference organizing quantitative data. So I hope you guys have a wonderful night. I will talk to you in the morning, and take care.